Hello everyone, it's Mr. Wolfe here, and in this video I am going to be going over scenario 5 for energy explanations that sometimes have a little bit of a different order of logic. So we have a tennis ball and a soccer ball, different masses, going at the same speed, experiencing the same friction, and the question is, how are their distances going to compare? In other words, is their mass going to change how far they're able to roll on the ground? So let's see. First of all, in order to answer this question above, we need to look at, well, here are my equations. K equals 1/2 mv squared, UG equals mgh, and work equals force times distance. And remember, I'm looking for distance, which is not in this equation, but it's in my work equation. So I need to look for work. All right, and I know that work is never in the initial and final. It's always going to be in the O section, which means that I need to focus at the end of my explanation here. I'm going to end at the O part, which means that I'm not going to go in that normal LOL order. Right? I need to kind of switch it up. I will say that it seems like I have enough information to talk about what's happening initially. Right? I kind of know the initial velocity, that they're on the ground, things like that. So I'm going to first start off by drawing that first L. All right? And in this section, let's say on ground. So first of all, just no potential energy. Let's see, same velocity, right? But soccer ball has more mass, which means, all right, if I look here, same velocity, more mass, that's going to give me more kinetic energy. So more K. So I'm going to draw that now. Notice that the blue here is always what I'm going to draw. Like I'm going to use the same color from LOL because this section is just saying, hey, this is what I drew. That's it. Red gives you the reasoning of why you drew what you did. So no potential, some kinetic for, I'm going to make this the tennis ball. Oh yeah, tennis ball right here, soccer ball. So tennis ball, not as much K. Soccer ball has more K because more mass. All right. So remember, I need to look at work, which means that I can't just go straight to the next O. I kind of have to look at what's going on after this. So let's see, the second L, all right, both on ground, no velocity. So there's no energy at all. I could say no K, no UG. I could also just say no energy, right? So that's it, nothing. I don't draw anything else. All right, so then now I can start talking about that, oh, I can start kind of figuring out what my work's going to be in order to eventually find out what my distance is going to be. So let's see, if I have this many blocks of K and there's none left, well, that means that 4 blocks must have left, right? Because you can't create or destroy energy, right? Same thing here. 2 blocks originally, 2 blocks leave my system. I'm going to say that, hey, this is work, and it's caused by, in this case, the force of friction of the grass. Force of friction. Force of friction. All right. So what I could say is, hey, the soccer ball started with more K. Maybe I'll just draw it right here. And as a result, right, more energy leaves system. I could also have just said more work. Like that totally works as well. All right. So here's an important thing is that what I have figured out is that they have the same work. Or sorry, that the soccer ball has more work. All right, so if I'm going to write a concluding statement, that means I'll use this equation, work equals force times distance, because I'm looking to figure out what that distance is going to be. And let me bring this up. I'm looking to see what this distance is going to be. I know from the problem that the force is locked in. It stays the same. Same grass, so same force. Right? But for the soccer ball, the work is more. So let's say more something that is more than 1 is 4, right? The force stays the same, so 1. So that distance would also have to be a bigger number as well. In this case, it would actually have to be 4. All right, I'm just kind of messing with numbers. And then I could kind of explain that. I could say, hey, force is the same, right? But soccer ball experiences more work, right? That's the same idea of more energy leaves the system. So more distance, right? I've talked about every variable of this equation, so I've accounted for everything that could possibly change. I know that this could be the only explanation that I have. So what I'd like you to, hopefully you could kind of make some fixes or give yourself a check if you did some good things, make revisions to how you attempted this problem. Thanks for watching.